Hello guys, welcome to Big Book. Today we are going to discuss on this lab practical estimation of sugar by Hagedorn Jenson method. So it's a TITRIMETRIC method of estimation of small amounts of glucose. In this, it's a kind of quantitative method of estimation. So in the further follow-up of the slides, we are going to discuss about the principle, reagents required, and the procedure and the results, and the table and the graph. So this first slide shows the every formula which has been depicted here. So coming to the next slide, in this slide we are discussing the principle. Here, as we know that the sugars are having the feature of reducing, like they are going to reduce a particular compound to the other form of its same. So in the principle it is very clear that the sugar solution is heated with excess of potassium ferricyanide. The ferricyanide present in the potassium ferricyanide is going to get reduced by the reducing sugars to form the ferrocyanide. So further, this ferrocyanide forms a precipitation with zinc sulfate and is not oxidized to ferricyanide by atmospheric oxygen. This is to avoid the reverse reaction where this particular ferricyanide is going to get precipitated as zinc salt. And further, whatever the remaining ferricyanide will be present, that will be determined with the potassium iodide. The potassium iodide will be added, and whatever the potassium iodide is added is going to get reacted with the ferricyanide and is going to give or liberate the gas iodine. Thus, the further the gas iodine is treated against sodium thiosulfate. Whatever the liberated iodine is titrated against the sodium thiosulfate using starch as the indicator. Starch is going to act as a blue indicator. So further, when we are going to treat this iodine, liberated iodine, then it is going to act as then it is going to react with the starch, and it is going to react with the sodium thiosulfate, where the color is going to colored liquid is going to get into the colorless form. So this is how we are going to indicate or identify the reactions. So here first reaction or the chemical equation is potassium ferricyanide is reduced by the glucose to the potassium ferrocyanide. In the next equation, the remaining potassium ferricyanide is going to get reacted with the potassium iodide, giving rise to the potassium ferrocyanide and the iodide. So this liberated iodine, further we are going to treat it with the sodium thiosulfate with the help of the starch indicator, and we are going to get the particular estimation. The last equation shows avoiding of the reverse reaction. Here in this we are seeing the addition of the zinc sulfate giving rise to the formation of the zinc salt and the potassium sulfate again. So here the last equation which we are observing. So here all these three equations shows a very clear image or the very clear clarity of this particular principle. Well guys, in this slide we are going to discuss about the reagents required. The first reagent we are going to prepare is the iodide sulfate chloride solution. In this we are going to take 25 grams of zinc sulfate and 12.5 grams of sodium chloride and dissolved in 500 ml of water. To this 500 ml of dissolved mixture of zinc sulfate and the sodium chloride, we are going to add 12.5 grams of potassium iodide on the day of the experiment, not to the previous days. So here further we are going to take 3% acetic acid. So we are going to make 3%, prepare the 3% acetic acid. Even this we can prepare on the day of the experiment itself. So in this we are going to take 100 ml of the distilled water and we are going to add 3 ml of the acetic acid to that. Further is to prepare the potassium ferricyanide solution. That is, we are going to take 0.82 grams of potassium ferricyanide in a dark bottle, and further 5.3 grams of anhydrous sodium carbonate is dissolved in water. Stored it in a dark bottle. So here we are going to prepare these solutions. So again we are going to prepare the sugar standard, that is standard sugar solution. That is, you know very well that 100 milligrams of sugar is dissolved in 100 ml, and take 10 ml of stock and make it up to 100 ml. So here from the standard sugar solution which we have prepared of the 100 ml with the 100 milligrams of sugar, out of that we are going to take 10 ml and we are going to make it up to 100 ml. So that is going to be this 10 ml, we are going to take it as the standard stock solution for the experiment. Further is 0.1 N sodium thiosulfate solution, 0.1 normality. Sometimes 1 normality is also used, sometimes N by 40 like ratio of the normality is also used. In some experiments, in some labs, it will be 0.005 normality of the sodium thiosulfate is also used. So here you no need to get confused between these different normalities. So this sodium thiosulfate at any normality at a particular volume, it gives the result. There is no need to worry. So 12.4 grams of sodium thiosulfate in 500 ml of distilled water we are going to dissolve. Starch indicator is the one where 1 gram of starch is in 100 ml of distilled water we are going to dissolve with the 5 grams of sodium chloride. So these are the requirements for the experiment. So here further we are going to discuss in this slide we are going to discuss the procedure. We are going to take 6 clean and dry test tubes which are used for the standard sugar solutions, which is going to range from blank to 0.4, 0.8 to till 2 ml. So here with the difference of 0.4 ml of the difference, we are going to increase the test tube range up to 2 ml. So it will be added, and further whatever the lesser volumes or which are less than 2 ml, to them we are going to add the distilled water to make it up to 2 ml. So we are going to take from blank itself, where blank will be added 2 ml. Further the next test tube will be added 1.6 ml, next will be added 1.2 ml, next will be added the 0.8 ml, and further we are going to add whatever the rest is there. And further we are going to take another 2 test tubes which is for the unknown solutions. That is, like, as we have taken the range of the standard sugar solution, to identify in the same manner we are going to take the 2 other test tubes. In that we are going to take standard unknown sugar solution, reducing sugar solution, to estimate the amount of the sugar present in it. Whatever the amount of the sugar we have dissolved in that we are going to take in that particular test tube. So those are labeled to be as the unknown. You can label it as unknown 1 and unknown 2 also. There is no need to worry. So here further, after doing this, then we are going to add 1 ml of potassium ferricyanide to each of the test tubes. So to all standard solution test tubes and also the unknown sugar solution test tubes, to all this we are going to add the 1 ml of the potassium ferricyanide, and we are going to, okay, you know that this potassium ferricyanide will be the mixture of the potassium ferricyanide and the sodium carbonate. So here this mixture is called to be as the alkaline or the anhydrous potassium ferricyanate, which will be added. It is not the directly prepared one. So further we are going to boil this all test tubes, all 8 test tubes. We are going to boil them, and we are going to boil it for 15 minutes in the water bath, and further we are going to cool it to the room temperature. Then after that we are going to add 1 ml of the acetic acid solution, and we are going to shake well. So whatever the 3% of the acetic acid solution which we have prepared already, from that to each test tube we are going to add 1 ml of the 3% acetic acid. Then we are going to add iodide sulfate chloride solution mixture. So you know that what is this mixture is, which is going to have potassium iodide, sulfate, sodium sulfate, and the sodium chloride. Further we are going to add this we are going to add up to the 4 ml on in each test tube. So we are going to shake it well after that. Now we are going to titrate the liberated iodine which is present in that. So here as I have spoken already that N by 40 sodium whatever the sodium thiosulfate has been used, it can be normality of N by 40 or 0.005 or 1 normal also, or 0.1 normal also. As per the requirement, the normality has been considered. So here we are going to titrate the liberated iodine against the sodium thiosulfate by using 1% starch solution. Titrate until the blue color disappears. In this slide we are seeing this particular protocol, where you can see the complete protocol which has to be followed. That is the first this column is of the test tubes, or sometimes depending upon the volume of the solutions we are using, we are going to take conical flask per the requirement. So and also conical flask will be very useful for swirling or the shaking or the mixing of the liquids which has been added further and further with the procedure. So here the second column is this one. In this you can see up to 6 it is this standard solution, and so 7 and 8 test tube is the unknown. Further is you are seeing the amount of the glucose which will be present in the standard solution. These readings are very much required to identify the unknown on the graph. So here further is the making up of the volume to 2 ml with distilled water. So here you can observe for the blank we have added 2 ml, 4.4, 1.6, 0.8, 1.2, 1.2, 0.8 distilled water, 1.6, 0.4 distilled water. Further here it will be 0. For the unknowns we are not going to add any distilled water. Further is after that we are going to add the 1 ml of the alkaline potassium ferricyanate in each test tube, and further we are going to heat the test tubes for 15 minutes and cool it, and further we are going to add 1 ml of 3% acetic acid in each test tube. Further we are going to add 4 ml of mixture of iodide, sulfate, chloride solution mixture in each test tube, and further we are going to titrate for the liberated iodine against the sodium thiosulfate. Again, these particular columns we will discuss after the next slide. So because we have taken these particular volumes and the formulas from the next slide. Well guys, in this slide we are going to discuss about the rundown of the sodium thiosulfate. I hope you know how to make a reading of the initial burette reading and the final burette reading. So here just to make a note, I will tell that if you take a test tube for the titration, you are going to run down the solution which is present in the burette. The initial reading is the one where the upper, before to the rundown of the solution, where the upper meniscus or the lower meniscus will be taken into the consideration depending upon the viscosity of the liquid. There the particular reading will be taken into the consideration and we are going to make a note of it. After the rundown of the solution and getting the result in that particular test tube or the conical flask. So as we have discussed in the procedure here in this lab practical, that after the rundown of the sodium thiosulfide and the conversion of the blue liquid to the colorless, whatever the volume has been used in the burette, that volume or the final burette reading for the test tube will be considered. So this will be the initial burette reading, this will be the final burette reading. For each test tube we are going to take the initial burette reading and the final burette reading. So here you don't get confused with the readings has been taken. Here again there is 0.1. It means that we have refilled the burette to take the further test tubes titration. So here whatever the initial reading and final reading will be there after the test tube titration, that has to be exactly taken into the consideration. So further in this column we are seeing the total volume of the sodium thiosulfate solution run down for each test tube will be recorded. It means whatever the initial reading will be present and the final reading will be present, both of the difference of the both initial reading and the final reading will be considered. So the difference or the subtraction is 4.6, 3.9, 3.2, 2.6, 1.9, 1.8 and 2 and the 2 volume. It is in the volume, that is ml. Further here we are going to calculate the value calculation for the thiosulfide used exactly for the particular potassium iodide. It means that whatever the iodide has been liberated, for that a particular amount has been sodium thiosulfate has been used. So that will be calculated on the basis of minusing the 4.6 with the minusing the VO with the V1. VO is the blank, VO is the blank, where the blank is the one which is going to nullify this particular volume out of this all other. So here when we are going to minus or subtract this nullified value from V1, it will be 0.7, 1.4, 2, 2.7, 3.8, 2.6 and 2.8. so this is going to be a particular rundown of the sodium thiosulfide for the liberated iodine. So this will be the volume of the sodium thiosulfide for the liberated iodine. So here these two columns has, not only these two columns, even this column has been. So here you can see now that in this previous protocol you can see volume of sodium thiosulfide and further the subtraction has been given the result. So this is the value calculation for the sodium thiosulfide run down against the liberated iodine. So here further we are going to plot these particular values on the graph. Now here during plotting of the graph we are going to consider only two columns within the overall protocol. One is the amount of the glucose in milligrams, that is the whatever the third column we had, that one, and also the last column which we have got. So this is what. So here these two columns we are going to consider and we are going to plot. In this graph we have plotted these values. To the x-axis we have given amount of glucose in mg, and against to the y-axis we have given the rundown of the sodium thiosulfate, the amount of the sodium thiosulfate rundown. So here, as we are estimating the reducing sugar, we have to take exact values which are present in the column here on the x-axis. And for the sodium thiosulfate, we are going to take a particular range, can be of 1, 2, 3, 4 ml, like that also, or else whatever here has been depicted. And further we are going to take a curve placed here. So here you can see that from here for 0.7, 1.4, 2.0, 2.7, 3.8 till 6, from second test tube to the 6th test tube, all 5 values has to be placed here. Okay, now here further we are going to make the unknown interacting. So here unknown, we are getting the sodium thiosulfate rundown of 2.6. so this is 2.5 is the value of the sodium thiosulfate rundown, and here it is going to interact here. So the fall of the interaction will be on the x-axis at 1.5 value. So here 1.5 value is the mg, 1.5 milligrams. So here further we are going to calculate this in the form of the formula. Before to that we will understand this 2 ml of the unknown solution is having 1.5 milligrams of the sugar. So here, considering the coordinating points in the graph, the 2 ml makeup of this solution is having 1.5 milligrams of the reduced sugar. Therefore, the amount of the sugar in the whole of the given solution is 1.5 into 100 divided by 2. Here we are considering it to be as the 100. We are producing this 1.5 into 100. It is because we have to calculate for the 100 ml of the solution. So here we are taking 2 as the denominator or the division value. That is because this 1.5 ml is in the 2 ml of the solution. So here the overall 100 ml of the reducing sugar solution, unknown solution, is having 75 milligrams of the reducing sugar solution. So the result is that the unknown solution contains 75 milligrams of the reducing sugar. So this is about the lab practical of estimation of sugar by Hagedorn Jenson method, and I hope I am very much audible, clear in explaining the concept and the procedure and the principle. And I request all of my subscribers or the watchers of these videos and whoever likes these videos to spread among others the word of this big book, and also help me to take new topics which is required by you in the huge volume. And I thank you for watching my videos.